Hello students, welcome to EDAMIGO, an initiative by GATE ECE Top 3 Rankers. So I welcome you all to the lecture series on previous year GATE questions on the subject of signals and systems, electronics and communication, and the topic is basics of signals and systems. Here we are solving the questions and also clarifying the concepts which are hidden in the question. So we have already completed 6 parts of the lecture series. This is part 7 of the lecture series. So let's start with the questions. So this is a very simple question. It is given that two systems with impulse responses H1T and H2T are connected in cascade. Then the overall impulse response of the cascaded system is given by. Okay. So it is given that two systems, LTI systems, are connected in cascade. Okay. So we have to find the impulse response of the equivalent system, a single system which is equivalent to this cascade connection. So now let us assume that if the input is xt, then at this point the signal will be xt convolve h1t, because we know that the output from an LTI system is equals to the convolution of input with the impulse response. Okay, now this is the input to the second system, and thus the output will be input, that is xt convolve h1t whole convolved with h2t, because this is the input and this is the impulse response. So we can say that the output yt is equals to xt convolve h1t whole convolved h2t. Now as we know that convolution has a property that a convolve b convolve c is equals to a convolve b convolve c. That is, if we want to find the convolution of, so this is the property of convolution, that is, convolution of three signals can be found by first convolving the two signals and then convolving the result with the third signal. So it can be done like this also. First of all we convolve b and c and then convolve the result with a, then also the result will be same, and this property is called associative property of convolution. Now using this property we can say that yt is equal to xt, so changing the bracket, multiplied by, convolved with h1t convolve h2t. Now if we say that this is equal to ht, so xt is equals to yt is equals to xt convolve ht, where ht is equals to h1t convolve h2t. Now using this equation, for let us say this is equation number 1, using equation number 1 and equation number 2 we can say that if input is xt and output is yt, then this is the LTI system which has impulse response ht is equals to h1t convolve h2t. So the cascade of h1t and h2t system can be replaced by a single LTI system having the impulse response equals to ht equal to h1t convolve h2t. So we can say that the overall impulse response of the cascade is given by the convolution of h1t and h2t. So C is the correct answer. So it's a simple question. Okay. Now let's move to the next question. It is given that the impulse response is this. We have to find the value of step response at t equals to 2. Okay. So step response is equal to ut input convolve the impulse response. Okay, so that is ut convolve impulse response is delta t minus 1 plus delta t minus 3. As we know that xt convolve delta t plus b is equals to xt plus b. So we have seen this in the previous section of the lecture series. So we can say that the impulse response will be equals to this convolution ut convolve delta t minus 1 plus ut convolve delta t minus 3. That is ut minus 1 ut minus 3 is delta is st. That is the step response. Okay, now if we plot st, then we can see that this term will start from t equal to 1 and this term will start from t equal to 3. So at t before t equal to 1 this will be 0. At t equal to 1 ut minus 1 will start giving the value 1.0, and from t equal to 3 this will also give us 1. So from 3 the value will be 2.0. Now we have to find the value of step response at t equal to 2. So we can say that at t equal to 2 the step response has value equal to 1.0. So B is the correct answer. Okay, so this was a simple question. Now the third question. Okay, so first of all it is given that xn is the input to the system, yn is the output of the system, and this is the relationship given between output and input. And we have to find that is the system linear or non-linear, stable or unstable, invertible or non-invertible. So we have to find these three things. Now we already know how to find that the system is linear or not, how to find stable or not. We will understand how to find the system is invertible or non-invertible. Okay, so first of all let me solve for linear and stability. We know the method, so I will just solve it because we have seen the method in the previous part of the lecture series. So if you have not gone through that, please go through that and understand how to find the linearity and stability of the system. Okay, so first to find linearity of the system. Now as we can see that yn equals to sine 5 pi by 6 n into xn. Okay, now this is the output and this is the input. So for x1n, output y1n will be equal to sine 5 pi n by 6 into x1n. For x2n, the output y2n will be equal to sine 5 pi n by 6 into x2n. Now let the input is ax1n plus bx2n. The output yout n will be equal to sine 5 pi n by 6 multiplied by the input, and the input is ax1n plus bx2n, and we can see that this is equal to a times y1n plus b times y2n. So we can say that this system follows the superposition theorem. The superposition theorem, and thus it is a linear system. Okay, now let's check the stability. So we used to check BIBO stability. What is the meaning of BIBO? I've already explained it in the previous section of the lecture series, so I will not explain it again. Now for checking BIBO stability, we apply input. As we know the method, we apply input, that is UN, which is a bounded input. And we can see that the output yn will be equal to sine 5 pi by 6n into un. And we can see that for bounded input un, the output is also bounded, because sine will always give a value between -1 and 1, and un has always a value between 0 and 1 only. So we can say that yn will always be a bounded output. Okay, so we can say that for bounded input we are getting the bounded output, and thus system is stable. Okay, now let me tell you the method to find system is invertible or not. To find system is invertible or not. So first of all, let me see what is the meaning of invertibility. Suppose I have xt or xn as an input to an LTI system or any system, okay, not LTI only. So any system. So this is any system, and we have the output which is yt or yn. Okay, so the system is invertible only when we can find xt using yt. Okay, so this is the meaning of invertibility. This is very important. First of all, you need to understand this. That is, if this is a system where input is xt and output is yt, now this system will be invertible, will be called as invertible system only when using yt, that is by computation of yt, by analyzing yt, we can find the xt, the input. That is, if by analyzing the output we can find the input of the system, then that system is called the invertible system. Okay, now let's analyze this statement or this definition. That is, from yt we need to find xt. Now this is possible only when yt has all information about xt. Okay, this is very important. This statement is very important, that yt must have all information about xt. Okay, so to check that system is invertible or not, we will follow this method. And the method is, first of all, we will check that yt or yn must have all information about xt or xn. That is, there should be no missing information. For example, here in this case, if there is missing information, then system is non-invertible. For example, yn is equal to sine 5 pi by 6n into xn. Okay, so this is the system given to us in the question. So we can see that y0 is equals to 0 multiplied by x0. Okay, y1 is equals to sine 5 pi by 6 into x1. So y1 has the information of x1. Similarly, y2 will have the information of x2, that is sine 10 pi by 6 into x2. y3 will have the information of x3. Okay, but y0 is equal to 0. So x0 information is lost. That is, if we try to recover xn, we will never be able to find the value of x0. Okay, so this is lost. We can get x1, x2, x3 from y1, y2 and y3. Similarly, if you look at y6, that will be equal to sine 5 pi into x6. So again it is 0 into x6. So the information of x6 is lost, and no other term of output will have the information of x6. Okay, only y6 can have the information of x6, and y6 is 0. So x's information, x0 information, x12 information, all this will be lost, and that's why this system will be non-invertible, because there is a loss of information due to the system is actually converting xn to yn, and there is a loss of information of xn. Yn does not has all the information of xn. That's why you cannot recover xn from yn, and that's why this system is non-invertible. Now the second thing that you need to look, so this question is solved. The second thing that you can look at, another kind of possibility of checking invertible and non-invertible, is there should be one-to-one mapping between output and input. For example, let us say yt is equals to sine of xt. Okay, now we can see that xt can have any value, but yt will have a value between -1 and 1 only. Okay, so now let us say that if yt is equal to 1, then 1 is equals to sine of xt, then at that particular time xt can have a value is equals to pi by 2, can have a value is equals to 5 pi by 2, can have a value is equals to -3 pi by 2, and so on. Okay, so for many values of input, okay, so at that time instant, whenever output is equal to 1, the value of input can be pi by 2, 5 pi by 2, -3 pi by 2, and so on. There can be infinite values. So there is many to one mapping taking place, that for single value of output there are many values of input that are possible. Okay, so in these systems are also non-invertible, because by looking at the output we cannot tell the exact value of the input. So such systems are also non-invertible. Okay, so I have told you how to look at invertible and non-invertible systems, and in this case the system is linear, stable and non-invertible. So it is linear, stable and non-invertible. So C is the correct answer to the question. So we will stop here in this section of the lecture series. We will be continuing the same topic in the next part of the lecture series. So thank you students. keep sharing these lectures and subscribe to the channel and give us your feedback. Thank you.